But nephrons are the basic units or the basic structures of the kidneys, where all the process of what? Filtration, secretion, and excretion taking place. So these are called nephrons. Okay. So nephrons are the basic structures of the kidneys. And which things do take place? Here, filtration, okay, secretion, and excretion is taking place here. Okay, these are microscopic units, okay, they are microscopic, we can see them with our naked eyes. Okay, these are microscopic, but I will show you the microscopic. They are microscopic. Okay, what's happening is that in this, the medulla, these nephrons are located, okay, here. Okay, and they are important for that. How do they look like? Let me show you. Nephrons are like this. Can you see? Let's say if you take this one here, okay, you can see, can you see these ones? These are all the nephrons. So they look like this. Nephrons have different parts. Like this one is the glomerulus, for example. This is the proximal tubule, okay, distal tubule, and this is loop of Henle. This is the descending loop of Henle, this is the ascending loop of Henle, and this is the collecting duct. These are the different parts of the nephron. You want this? I can print out for you if you want.
So they are long, so that's why there's a lines inside the kidney, it shows like a line.
These ones?
Yeah.
This is when, you see, filtration takes place here in the glomerulus. Filtration means the blood will come here. This is called afferent arterial. These are arteries, okay? Afferent arterial, this efferent. That blood is coming to this glomerulus and it is being filtered out here. Can you see? The first part that's coming out here is filtration. So now, but it's not, up to now, it's not like urine, okay? It's just a filter. It's filtered out, then it's coming, while it's coming to the loop of Henle and like the descending and ascending, what's happening is that some chemicals or some structures that are unwanted will be removed from the tubes here. And some that are important not to skip out, they will be what? Absorbed back. Like glucose, for example, is important for the body. Proteins are important. They will be absorbed back. So that is what we call the secretion, or which is called the reabsorption part. I think I should have to say this one. Reabsorption and excretion. That will be first reabsorbed, and that is not important will be what? Secreted out. Okay? So here it will like filter out. There will be like filter out. The most important one will be absorbed. Those that are not important will be secreted. And then finally it's excreted as urine from the collecting duct. Okay? So this part is what we call a nephron. Everything is a nephron. Okay? Then if you see your picture, you have what? A renal pelvis. Can you see that structure or that part where this one, if you see this area here, this is called renal pelvis. At the renal pelvis, the arteries, the renal artery, the renal vein, and the ureter here. Can you see the ureter? All of these, they are found here. This area, this region is called renal pelvis. Pelvis means like like some container like this. Okay. So at this area, all the artery, the renal artery, the renal vein, and the ureter, they come in and out of the kidneys. So renal artery is what? The most important artery that supplies the kidney is called renal artery. So that's found where? At the renal pelvis. You can see it maybe there, yes?
Yes. This one? I think it's
Yes, that's the renal artery. So the other one is the renal vein. The renal artery,
The big one.
yes, it gets blood into the kidneys, and the vein takes blood away from the kidneys. And the ureter, it will take what? Urine away from the kidneys.
Kidney.
So all these three structures, renal artery, renal vein, and the ureter, they are found at the renal pelvis. So if you see the ureters, so the ureters at the end, they communicate or they contact with what? With the bladder.
Bladder.
Okay, and at the bladder, there are what we call small folds of the bladder mucosa, which are called like sphincters. Okay, they are like what we call sphincters. You see, if you see here, can you see the ureter? They come here, and they are attached with the bladder.
Bladder.
So here there are like what we call sphincters. So these sphincters, they are made up of the bladder mucosa. That means the layer, the inside layer of the bladder, and it prevents any backflow of urine to the urethra. Okay. So once urine flows or comes through the urethra, it should get in where? Into the bladder, yes? So it can't come out of the bladder and go back
It's
to the ureter. So there are sphincters that close and open, close and open. When urine is coming here, it will open and gets, then it will close. Then it doesn't allow the urine to backflow. Okay? That is called the sphincter here, the ureter sphincter here.
I have a question. If people have a catheter,
Catheter. So if they have catheter, it will get into the urethra here and it will stay in the bladder. It will stay in the bladder. And usually in the bladder, that it has like a balloon kind of stuff, so a balloon here, and it will inflate. The balloon will inflate. You can inflate it with like some fluid or water, okay? And then you can keep it like here. Let's say if you see here, for example, can you see here? So this is the, for example, catheter, okay? It's an important example is a Foley catheter. It's a very nice catheter, is the Foley catheter. So you can see, can you see? It gets, can you see this balloon here? The small balloon? This balloon here, so you create a balloon so that this ureter won't what? Slip out. So it will be there, it will stay there depending on how you need. Can you see here? It's also, so it will stay there.
last time I saw the blood on the catheter tube. Then what happened?
Blood?
Blood on
Yes,
the catheter.
maybe any structure inside is traumatized. Sometimes when you try to apply, when you put the, okay, it can be traumatized. The tissue, the layer of the urethra or the bladder can be traumatized, and you can have blood. Or if the patient has some conditions in the kidneys like stones and so on, you can have also blood in the urine. So any of this can create. It depends on the condition. So okay, so urinary bladder can hold how many ounces of urine? Around 15 ounces of urine. Okay, and urethra, which urethra is long? Man or woman urethra is longer?
Men's. 6 to
Man.
8 inches.
Okay, look how it's okay. In women is 1.5 inch. That's why urinary tract infection is more common in women because of shorter pathway or a shorter. Okay, you can see infections more than men. So urethra also has a sphincter. So that's how, let's say, when you try to pee, you can hold your urine or you can let it go. Yes, that's because of the sphincter. The sphincter will hold the urine, or it will release the urine. That's called urethral what? Sphincter.
Sphincter. Control is
Okay, so these sphincters are like muscles, and they allow the urine either to flow or you can hold it. And the bladder is also made up of a muscle. Bladder also is made up of it has a muscle here. If you see here, can you see? This muscle is called detrusor muscle. Detrusor muscle. So detrusor muscle is a muscle of the what? Bladder or the kidneys?
Teacher, I'm leaving.
Okay.
I don't feel good.
What happened?
Not my,
Huh?
not my.
Oh, okay. Okay. You can see urine is flowing. There is it's called detrusor muscle. Can you see detrusor muscle? Detrusor muscle is the muscle of the bladder, and when that muscle contracts, the urine will come out. And here, this area, can you see this area? These are the two orifices of the urethra. The urethra, can you see? And this is called the trigon. It's called the trigon. Okay, just highlight the detrusor muscle. This is called the trigon. Okay, trigon means this one, can you see? Trigon, where the two orifices is called urinary bladder trigon. Can you make the triangle there? Yes.
yes.
Make a triangle, that's trigon. No, just keep it. Okay. So men have stronger sphincter muscles which allow for more urine to be stored in. Okay. There is a little bit of discussion here on nephrons. So let me take you back to the nephrons. Nephrons. So you remember I discussed for you how they work, yes? So this is a nephron, okay? So you see this is one is what? The glomerulus. This is the glomerulus. This is called PCT, which is called proximal convoluted tubule, and this is distal. This is called loop of Henle. Loop of Henle, we have two kinds. One, the one that descends, called descending, and this one is ascending. Okay? So what's happening is that these are the arterioles, that means this is the afferent arteriole that brings blood into the glomerulus, and blood out of the glomerulus through efferent. This afferent, A means towards, to. E means away. Okay? So this inside are what's called the capillary tuft. That means these are the capillaries. Now filtration takes place where? Here, yes? That means the blood will be what? Filtered out. Okay? And those stuffs will come out, and the remaining blood goes out for against circulation here. So can you see the tubules here? They are surrounded by, like, can you see? Like capillaries. Can you see these ones? The ones that are surrounded like network of capillaries. Can you see? These are called vasa recta. These are called vasa recta. Okay. Which picture do you like? I think I can print out this one for you. You want that? So it is telling you everything. All this page on page 97. On page 97 is this picture. If it's good if you study all these things with the pictures, because there is no like picture here, so this is
Yes, we read, we don't know what's that means.
yeah. So that's how I'm giving you this one. Now this is everything on what? The nephrons. Okay, everything on the nephron. So that means everything on page 97 is this picture. So you can see this one is what? Now it says glomerular. So nephron means everything, okay? Everything, this one is a nephron. This is what? A glomerulus, like the head. Okay? Now, let's go to the glomerulus here, the second part. Let's go to the glomerulus. It says Bowman's capsule. Can you see Bowman's capsule? This is the Bowman's capsule here. Bowman's capsule. Write it there. Bowman's capsule. This is a cup-shaped structure. It's like this, you know? It's like this, yes? It's like a cup. Yeah?
So
This-
is called glomerulus capsule.
Yeah, this is called Bowman's capsule. Bowman's.
Not glomerulus.
Yeah, everything is a glomerulus. But this one where the capillary tuft or where the arterioles are getting inside, that is the Bowman's capsule. Okay, you can see it here. This Bowman's capsule. You can underline that. So can you see the name vasa recta? It then moves into the vasa recta. Okay, so what are the vasa recta? Vasa recta are these ones, can you see? Okay, now how is the process? Blood is coming from the renal arteries, okay? Okay, it should be what? Filtered in the nephrons, yes? So, through the afferent arteriole, blood is coming into the, you can see the glomerulus, yes? And then, from here, some of the toxic things will be what? Filtered here. This is F. It's filtered here, yes? And the remaining, where it's like clean blood, will be what? Will be moving to the efferent arteriole. Then this efferent arteriole, it becomes like vasa recta here. This is called vasa recta. Now, when the toxic blood is coming here now, when it's moving, some structures will be what? Will be secreted. Those that are toxic still in the blood, they are what? Removed with the capillaries here, with the vasa recta. The vasa recta will pull them. For example, if it is like glucose, hey glucose, I need you. Protein, I need you. Some fats that are important for the body, I need you. They don't need to be what? Excreted out of the, okay? And then some of them that are not important will be what? From the vasa recta, they will be secreted back into the tube. Like, for example, ammonia or some toxic things, they will be secreted back. Now everything will be collected and then it will go out through the, what we call the distal convoluted tubule, this one, and then in the collecting duct, there is no reabsorption, there is no secretion. That's it. It will go out and it will go to where? To the renal pelvis, where there is what? The ureter, and then the ureter will take out what's called urine. Okay, so that's what is telling you here on the glomerulus. And if you see the next one, afferent and efferent arterioles, can you see here? So this is the one that's called afferent and efferent. Okay, afferent arteriole is this one. The one that takes in blood to the glomerulus, and the one that takes out is efferent. This is the capillary tuft, where the capillary, where there is what? An exchange of what? Especially filtration, it will be filtered out. Yes, okay? It will be filtered out here. Okay? That's what afferent and efferent arteriole are here. And can you see on the afferent and efferent arteriole there is what we call interlobular arteries. This is the one. Can you see it here? It's interlobular. Can you see? The big one? Can you see the big artery?
Okay.
Okay. So what's happening is that which artery supplies the kidneys in general? What's the name of the artery that supplies the kidneys? Renal artery. Now that renal artery is big, okay, when it comes into the kidneys, it's what? It's big, yes? But at the end, it should go to each what? Nephron. So it should be divided, splitted back, split.
And become narrow.
Become very narrow, small. Because to reach to each what? To each nephron. Okay? So if you see that segmentation, how the branches are coming is a little bit. Can you see here? You see? This one is the renal artery. Can you see here? This is the renal artery. This is the renal artery. Then look, it's becoming splitting to divide into the very small. So look, first it becomes like what? Segmental artery, then lobar artery, then interlobar artery, then arcuate artery, interlobular artery, then the small one, afferent arteriole. You see? That's what here is telling you. It's a branch of what? Interlobular artery. Can you see? It means the final one that comes. Okay, before it becomes what? Afferent arteriole, it is what? Interlobular. Before interlobular is what? Interlobar. Before that is what? Arcuate. Before arcuate is what? Segmental. Before that is what? Renal artery. Okay? It becomes like divides into and gets to the small division and becomes the afferent arteriole. Then the afferent arteriole, and the afferent will become the capillary tuft in the glomerulus. Then that is the one that makes that filtration in the glomerulus. Okay? Then finally when it comes out from the capillary tuft and becomes what? What? Efferent arteriole is the same. Yeah, again the same step to be what? To be big. Okay? It means the efferent arteriole will become what? Interlobular, and then interlobar, then what? Arcuate, then what? Segmental, and then the renal artery. Okay? So that's what. Look, can you see here? Look how. Look, this is the renal artery. Then look how it's being divided. Look. Then becomes small. Look. Becomes smaller. Look, now it's trying to supply the medulla here and the cortex to supply. These are arcuate arteries. These are arcuate. Okay? Finally, it gets inside to the small nephrons and glomerulus.
And actually each bundle of nephrons, they get the ducts,
Yes.
The yellow one?
Huh?
The
Which
yellow
one?
structure.
This one?
Yeah.
No, this is finally it becomes the ureter here. That means can you see this is the pelvis, yes? This area is the pelvis. Now this is the pelvis, this is the, can you see? This is the pelvis area. Look, this also becomes like, these are called calyx. These are called minor and major calyx. These are minor calyx. The minor calyx becomes major calyx. Can you see here? These are major calyx. These are minor calyx. That means first they are small, then they become, by joining, they become more big, and then they form the pelvis here. Then the urine can go, everything drop there on the pelvis, and the ureter will take it to the bladder. So these are called minor and major calyx.
So they collect the urine.
Yes, they collect the urine. That's after, in the collecting duct, you remember that one, the collecting duct? Can you see all of you the collecting duct?
Yes.
So you see the collecting duct becomes a minor calyx. Okay, then the minor calyx becomes, more minor calyx will be joining and they become major calyx. Then it will form this one, the pelvis. Okay? So that's what this one is showing you. As I told you, the Bowman's capsule is the capsule that covers here at the end. You can see Bowman's capsule, or it's called glomerular capsule. It has two layers, visceral and parietal. The visceral means the inside. The inside one is called visceral. Well, it's where it's really communicating with the capillary tufts. And then you have the outside one, which is called the parietal. So let's see glomerulus in a big, okay? Okay, this is, look, the microscopic structure of a glomerulus. This is how, if you see it. So it means this is the capsule, can you see? And these are the capillaries, can you see? Okay? This is what I want. Can you see? Now, this is the afferent arteriole. Then this becomes what? The capillary tuft or the glomerular tuft, and then the efferent, yes? So this is the Bowman's capsule, can you see? Yes? So the Bowman's capsule, it's like World Cup, can you see? Yeah? So it has two layers now. Visceral is the inside one, this one. Parietal is this one. Okay? Visceral, parietal. So the visceral one is covered by what we call simple squamous cells. And the parietal is also with squamous cells. Why they are squamous cells? Squamous means what? They are simple flat cells. Why? Because it's easy for filtration to happen. Because they are like a floor tire. You know, floor tire is very one layer and it doesn't have more layers on it. Squamous cells are single layers. So they don't have more layers on top of them. So that you see absorption or any filtration won't be like difficult. So because it's a filtration area, so that's how structures are being made. For example, you can't put this layer on the stomach. Yes? Because stomach needs what? It should be what? Very strong to digest many things. But like lungs and like kidneys, like this glomerular, they have a very simple layer, which is called squamous cells. Squamous cells, simple single layers.
Excuse me, sir. These structures that we see inside of the kidney, I think they're all Bowman's capsules.
Eh?
They're all.
No.
They're
Bowman's
all-
capsules are
just
histological.
one? Is it just
You
one?
can't see them here. You can't see them
Okay.
in the eyes. These are histological. We see them under the microscope.
Oh,
That's why I showed you here. This is under the microscope.
oh, okay.
You see, when you see under the microscope, this one is the glomerulus. So this is the Bowman's capsule. These are here the tubes, the tubules. You see, you know, we say the tube, the Henle, loop of Henle, and the proximal and distal convoluted tubule. Yeah? So when you see, let me write for you the different parts of the nephrons. Nephrons, when we discuss nephrons, what do we have? We have the glomerulus. The glomerulus, okay? The glomerulus has what? The afferent and efferent arterioles, and we have the Bowman's capsule, okay? And the capillary tuft inside, okay? Just for you to make it afferent, Bowman's capsule, and okay. Then you have what we call PCT. PCT means proximal convoluted tubule. PCT. Then you have loop of Henle. Loop of Henle, we have the descending, the one that's going down, and ascending, the one that goes up. You know, it's coming down and dipping inside to do some reabsorption and secretion. Then it's going up to take all the fluid up. Okay, so loop of Henle, that's descending and ascending. Then after loop of Henle will be what? What's after loop of Henle? We have PCT, then we have DCT. Okay, PCT is proximal, then we have what? Distal. Okay, we have distal convoluted tubule. Then after this we have what? Collecting duct. Collecting duct, that's the final. Okay, it will take all the final excreted urine into the ureters. Okay, so that is how nephrons are being made of. Then when we go to, I will print out this one for you. Then we have the minor and what? Major calyx, and this minor and major calyx, they form what? The pelvis. The pelvis. The minor calyx, they form what? The major calyx. The minor calyx form major calyx, and then the major calyx form the pelvis. At the pelvis. Then it will go to the ureters. Then the kidney ureters to bladder. From the bladder to the urethra. So that's how it goes. Then from the ureters to what? Bladder. Then bladder to. Then I don't know where it goes. Huh? So that will be how it's going. Okay, so that means everything on this page, you see on page 97 is compact, and everything that you got it will be here. So you can see on next page is the same. So can you see proximal convoluted tubule, distal convoluted tubule?
Yeah.
So that means no this picture, you see, no this picture. Once you know how this picture works, then it's easy to understand which one is PCT, proximal convoluted tubule, which one is distal convoluted tubule, or DCT. Okay, I think let's stop here. Next time, can you remind me on page 99, or maybe if you want, we can skip this chapter and we can go to the other chapter, or we can finish it here on page 99.